Hey friends, a video here on how to solve the quadratic equation using either the quadratic formula or by factoring. So first we'll use the quadratic formula. And we want to remember in the quadratic formula it needs to be in standard form. As long as it's in standard form, the first term is a, or the term in front of x, the constant in front of x squared is a. In front of x is b. And the constant, the term without a variable, is c. And then we just put it in the quadratic formula. So we say x is equal to the opposite of 32 plus and minus the square root of 32 squared minus 4 times a times c. All of that is being divided by 2 times a. And then I would tell you to take the part inside the radical. So this piece right here. And put it in your calculator. And when you put it in your calculator, you get x equals negative 32 plus and minus the square root of over negative 6. And then in your calculator, go to Canvas, go to calculator, let's get rid of all those other ones. And in our calculator, we are going to put b squared, so b was 32, close in, square it, minus 4 times a, which was negative 3, times c, which was negative 45. And we get 484. So we get 484, which then say I have x equals negative 32 plus minus something over negative 6 and 484. I would grab my calculator again. I would go y equals 484 divided by x squared, table, and whoop, right there we go, 11.4, nope, is there one smaller? Nope, there's no one smaller. It can't be 11 square root of 4. Oh, is it perfect? It's perfect. Square root of 484 is 22, so it's perfect. So 22, so that would be x equals negative 32 minus 22 divided by negative 6, and negative 32 plus 22 divided by negative 6. And that would be negative 54 divided by negative 6, which is 9. And that would be negative 10 over negative 6, which is 5/3. So our answer would be 5/3 and 9. That's what we would put in Canvas. And let's see if it fits. 5/3 and 9. Let's go back to our calculator. 5/3. So that would be negative 3 5/3 squared plus 32 5/3 minus 45 should equal 0. It does. And then the other answer I had was 9. So let's put 9 there. And let's put 9 there. And it works. Those are our answers. All right. Number 2. All right. So we would have x is equal to the opposite of b plus and minus b squared minus 4ac all divided by twice a. So x would equal negative 22 plus the square root of something over 6. And I'll grab my calculator. There we go. And I would go y equals. And we don't want y equals. We want just the regular calculator. We would say we have b squared minus 4 times a times c. And we would get 400, and that is 4 times 100, which is 20. Square root of 400 is 20. Okay, so we're going to say, dun dun dun. Well, this is 400, since we had that there. X equals negative 22 minus 20 divided by 6. And x equals negative 22 plus 20 divided by 6. Oh, I have some of these that don't come out to be maybe the next one. X equals negative 42 over 6, which is negative 7. And x equals negative 1/3. So our answers are negative 7. Hello. Let's write it twice. Negative 7 and negative 1/3. And if we want to check our work, we can go to our calculator. And in our calculator, we can put the problem. We're going to say the problem was 3 times negative 1/3 squared plus 22 times negative 1/3. And then plus 7. And I should get 0. And I don't. Oh, that's because I did not type this in correctly. Negative 1. Got the fraction bar. Second inner fraction bar. There we go. Now we get 0. And our other answer was what? What was our other answer? Negative 7. So if we put in negative 7, second inner, negative 7. So put negative 7 in there. And delete. And negative 7 in here. 7. Enter. Oh, the parenthesis didn't get closed. Insert. Nope. Let's bring it back and let's close the parenthesis. Right here. Second, insert a parenthesis. There we go. And we get 0. So that worked. We could have also gone y equals. Oh, it went to sleep. Dang it. Foolish calculator. Back to Canvas. Open another one. Sometimes the ones online fall asleep, give themselves up. I think it's really the iPad more than it is the calculator technology. The other thing we could have done is we could have just put in the problem. 3x x squared plus 22x plus 7. We could have graphed it to see where it crosses. And it crosses at -7. And it's hard to tell where it crosses there between 0 and -1. But if you want to check yourself, you could go table set. And you can ask it for -1/3. And go to the table. And at -1/3 gives you the answer 0. So you would know it that way also. All right. Okay, moving on. Okay, this one. X equals the opposite of b, plus and minus b squared minus 4 times a times c divided by twice a would be x equals 2 plus and minus the square root of 2. That would be 4 plus 16, which is 20. And that would be x equals 2 plus and minus 2 root 5 divided by 2. So then you would have x equals 2 halves plus and minus 2 radical 5 over 2. And these would cancel each other out, so with those. So your answer would be x equals 1 plus and minus root 5. And then you can still check your answer. Even though you got an irrational number, you go to your calculator. And you could put in, what was it, 1 plus the square root of 5, which is x, square it, minus 2 parentheses 1 plus the square root of 5 minus 4, and it should equal 0, and it does. And if you change them to the minuses, it works. So that's your answer. And since it's an irrational answer, you just type it just like that in Canvas. Call her done. All right, last one of these. X equals the opposite of b plus and minus b squared minus 4 a c divided by 2 times a. So you get x equals -3 plus and minus 9 plus 49 over 4, which would be x equals -3 plus and minus 7 over 4, which is x equals -3 minus 7 over 4, and x equals -3 plus 7 over 4. That would be x equals -10/4, which is -5 halves, and 4 over 4, which is 1. So your answer in Canvas is -5 halves and 1. And then again, you can put it in your calculator and see if it works. And if you put it in your calculator, -5 halves was our answer, right? So we would have 2 parentheses -5 halves squared plus 3 -5 halves minus 5. That gets you 0, and the other answer was 1, right? 1, delete, 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 and seems ridiculous using 1. Delete, delete, delete. But there we are. Okay. So now, let's try by factoring. Okay, so by factoring, I want the factors of positive 24 that add to negative 11. They are negative 3 and negative 8. So x minus 3, x minus 8 is 0, x equals 3, x equals 8. We're going to do this two ways. Here, let me put it in here twice. Copy. All right, the first way we're going to do it is we're going to say that 3 times 7 is 21, and the middle number is 22. So I want 1 and 21. So that is x plus 1 and x plus 21 equals 0. So x is negative 1 and x is negative 21. That work? Negative 1 and negative 21. Yes, that works. We'll see if it works. Double check. Negative 1 and negative 21. Let's do the negative 21 first. And this was the second one, right? So 3 parentheses, negative 21 squared plus 22 times negative 21, and then plus 7. And it should equal 0. And it doesn't. I can't believe the easiest problem on the page I did wrong. The factors of 21 that add up to 22 are 1 and 21. Oh, negative 1 and negative 21. Did I put negatives in? I did put negatives in. 3. Okay, let me do it the other way and see if I can figure out what my mistake is on that. All right, way number 2. Because I wouldn't do it that way. Maybe that's why. I would have 3, and I would have x, because those get you this. And then I would put 7, and I would put 1, and those would get you this. And so this would be negative 1/3, and this would be negative 7. What did I not do right? Oh, duh. All right. Yep, this is why I don't do it this way. Foolish me. Woo, okay, so let's go back to this. Hang on, let me grab all of this and move it down here, out of the way. There we go. All right. I forgot how to do it by splitting the middle term. 3x squared. There we go. Plus 1x plus 21x plus 7 equals 0. Okay, I remember. It came back to me. It's all coming back. This number right here, this term goes here, and this term goes here. Then we do this times this, which is this number. And the middle term is here. And then we take this number, it's there, and this number is there. Wow. Mrs. Leonard, brain freeze. Okay, then we're going to go by grouping. We're going to look at these two terms and these two terms. We're going to say the common factor here is x, and that leaves us 3x plus 1. There we go. And the common factor here is 7, and that leaves us 3x plus 1. This is it. I'm back now. 3x plus 1 and x plus 7 equals 0. 3x plus 1 equals 0. X plus 7 equals 0. x equals negative 1/3, x equals negative 7. Yep. Sorry, friends, my brain went away for a half a second, but it came back. But that's how we do that. The other one I just did by guess and check. So the other way I did it by guess and check, and obviously I'm better at guess and check than I am at splitting the middle. So on this one, we'll do this both ways also. Copy. Okay, so by splitting the middle, which is probably the one that you guys like the most because that's how your algebra teachers taught it to you the past 3 years. So we're going to split the middle. So to split the middle before I make any mistakes, I first write this down and I write this down. So I'm going to write 2x squared minus 5 equals 0. Then I'm going to take the first term times the last term, and that's going to get me negative 10. Then I'm going to look at the middle term, which is 3, and then the factors of negative 10 and 3, negative 10 that add to 3 are negative 2 and 5. And so I'm going to put negative 2x and 5x right here. Then I am going to consider the first two terms and the last two terms as individual binomials. The first 2x squared minus 2x have a 2x in common, leaving you x minus 1. The next 5x minus 5 have 5 in common, leaving you x minus 1. Those have x minus 1 in common, leaving you 2x plus 5. This is x equals 1, and this is x equals negative 5 halves. So that's your answer. Okay. Going with just guess and check. And friends, guess and check, I think, is easier, especially when your first term is a prime number and your last term is a prime number. If those are prime numbers or numbers with very few factors, you know if 2x squared is in the first term, then one of these has to be 2x and one of these has to be x. Because when you multiply them together, when you take this times this, they have to equal 2x squared. Okay? So then your choice, all right? So then you're left, I'm going to copy this. Copy, paste. So then you're left with some choices. Okay? Then you're left with, I didn't want to do that. I wanted to do this. Then you have this factor over here, this factor of negative 5. Okay? That means you have choices. You're either going to have the 5 here and the 1 here, or the 1 and then the 5. It's going to be one of those two things. Okay? And then you have to weigh in the fact that you have this positive 3. So, and your signs have to be different. So if you make this positive and negative, then when you multiply, when you take this times this, you get negative 2x. And when you take this times this, you get positive 5x, which winner, winner, chicken dinner is 3x, which is what you want. So that's the proper factorization. If you did it this way, you did plus minus, then this times this would get you negative 10x, and this would get you 1x, which would get you negative 9x, which didn't work. Okay? So, that's the way that worked. So So that's the factoring, and then you set it equal to 0 and solve, and that's going to get you negative 5 halves x and 1. So negative 5 halves and 1. So I do guess and check when my numbers are nice, easy to manipulate numbers. Okay? This next one is not nice, easy to manipulate numbers. But at least it doesn't have a number in front of x squared, so I can at least start. But I need the factors of 176 that add to negative 48. And I don't know all the factors of 176. And I don't want to make a list. So here's what I'm going to do. I'm going to go to my calculator. And I'm going to end my calculator. Oh, it fell asleep. So let me go to Canvas and wake another calculator up. And in my calculator, I'm going to put in y equals 176 divided by x. And then I'm going to put 176 divided by x plus x. And then I'm going to look at my table. And the black and blue are the factors. You see, 1 times 76 gets you 76, yes? And 4 times 44 gets you 176. And 8 times 2 gets you 176. And 11 times 16 gets you 176. So these are all the factors of 176. 16 times 11 are 176. 22 times 8, okay? So the black and the blue are the factors, but what's really cool is the red. The red is the middle term. And the middle term we were looking for is negative 48. So we'll go back to our calculator. And we are looking for the red number that's negative 48. So we're looking in the red column for negative 48. Whoa, right there it is. So the factors are negative 4 and negative 44. Those are the factors of 176 that add to negative 48. So we're going to go negative 4 and negative 44. So we're going to go x minus 4 and x minus 44. So x is equal to 4 and x is equal to 44. Dinner, chicken dinner. By the way, we could have done that here as well if we wanted to solve this one by, we would have needed factors of negative 10 that add to 3. Anyway, so that's the really cool way to use your calculator to help you there with all of those things. Also notice, just for tickles and grins, that some of these are the same problems. We did 2 different ways. For instance, number 4 and number 7 are the same problem. Notice we got the same answer. So it doesn't matter which way we did it. Did I do that again anywhere? I thought I did that somewhere else. 3 and 7. Yes. Number 2. And dun, 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 dun. Number 6. We're the same problem. Tell me I got the same answer. Negative 1/3 and negative 7. Yes. Okay. Why 2 different ways? The quadratic formula will work for every quadratic equation in the world. There is not a problem, a quadratic problem, that the quadratic formula will not solve. Factoring will only solve them if there are factors. of AC that add to B. If there are factors of the product of the first and last term that add to the middle term, then factoring will work. If there are no such factors, then you can't factor. Okay, so guess and check and factoring are a sometimes will work, sometimes will not work, depending on the problem. Completing the square and solving the quadratic formula will work for any quadratic that you can imagine. All right, my friends, that's it. Have a great day. If you have any questions, please email me or ask me in class.